How is chaos defined in probability and statistics? Which state is more likely to last naturally, a messy room or a neatly organized one? Most people would say that if a room is left alone, it becomes messy again. Why does the world tend to move toward chaos rather than order? In science, this is explained using the concept of entropy. Entropy is a value that describes the degree of disorder. The more randomly things are mixed, the higher the entropy. The more neatly arranged they are, the lower the entropy. But here is something interesting. Chaos does not always mean something bad. In fact, nature often prefers chaos as a more stable state. Why is this so? Physicist Boltzmann discovered an important fact while studying the motion of tiny particles. Gas particles in the air do not move in neat lines. They move around in all directions. Yet strangely, when these chaotic movements come together, consistent patterns such as temperature and pressure appear. The small world is chaotic, but the larger world shows order. How is this possible? For example, what happens if ice is placed in hot water? Over time, the water becomes lukewarm. But lukewarm water does not naturally separate into hot water and cold ice. Why does change always move in one direction? Because the world moves in the direction of increasing entropy. Entropy is also very important in probability and statistics. Now think about flipping a coin. If heads and tails each have a 50% chance, is the result easy to predict? Probably not. But what if the chance of heads is 90% and tails is 10%? Then heads would be expected to appear more often. In this way, the harder it is to predict the outcome, the greater the entropy. On the other hand, if the outcome is easy to predict, the entropy is lower. In other words, entropy can be seen as a measure of how difficult something is to predict. Let us think about test scores. If most students score between 70 and 80, the scores are somewhat predictable. In this case, entropy is low. But what if one student gets 0, another gets 100, and another gets 50? The results vary too much to predict easily, so the entropy is higher. If a test is coming, but the test scope is completely unknown, it is hard to know what questions might appear. This can be very confusing. But what if the teacher says the test will focus on Chapter 3? Suddenly, the amount to prepare becomes smaller. In other words, as information increases, confusion decreases. That is why entropy is said to decrease as information increases. This is also one of the key goals of probability and statistics. It is about finding patterns in complex data to better predict the future. Weather forecasting works the same way. It analyzes vast amounts of data on temperature, wind, and humidity to reduce uncertainty. Then why are weather forecasts not perfectly accurate? Because the entropy of nature is too great. AI also calculates entropy as it classifies data. It looks for the criterion that reduces confusion the most. For example, when classifying fruit images, color may be the most useful feature, or shape may matter more. AI learns which information most effectively reduces uncertainty. At first, the world seems confusing and complex, but probability and statistics seek the hidden patterns within it. Perhaps mathematics is the study of finding order in chaos. What patterns can be found in the complex phenomena around us?